Good evening. So last session we learned what are generics and enums. In TypeScript, generics and enums, how to deal with them. One more option is about modules. How do we work with module system? Technically, I hope you already learned modules in JavaScript. Same. I once explained a little overview about modules in JavaScript because React all uses module system. I already explained once. Once detail we will see. What is a module actually? So a module is a set of variables, classes, functions. So contracts, enums, etc. Everything can be inside a module. It's a set of variables, classes, functions, contracts, enums, everything present in a module. What is the advantage? What is the purpose? Is module system. Module system allows to build a library for application. You can build a library for application. So you can design a library for application. So what is a library? You already know. Library is a set of values and functions which you can use in your application. Actually, module system allows to build a library for application, and usually JavaScript based technologies. JavaScript based technologies uses various module systems, which already I explained in one scenario. If you remembered in the beginning, I told you UMD, AMD. In React, we use a data system. Various module systems, JavaScript based technologies. What are those module systems we have? CommonJS is a module system. Require.js is a module system. So UMD is a module system. Universal module distribution. Universal module distribution. We have like AMD. So async module distribution. These are all various module systems. And actually, TypeScript, when you install TypeScript by default uses CommonJS. CommonJS has module system. Without a module system configured, modules cannot work. In order to use module system, you must have a module system installed. Actually, when you install TypeScript, it installs a module system called CommonJS. When you install Node.js, you will get a module system, AMD, UMD like module systems will be there. Directly, module systems are not available in any device. You have to install them. And sometimes you don't need to install explicitly, separately. You get them along with the JavaScript based technologies. And the TypeScript uses CommonJS as module system. You see here, this is our project. And in our project, we have the TypeScript project here. In this TypeScript project, we can configure the rules for TypeScript in tsconfig file. And if you go to tsconfig file, in the tsconfig file, you see the target JavaScript is ES 2020. And you can observe the module system is CommonJS. So by default, the module system is right. That means TypeScript uses a module system and it needs a module system for building library. So what is advantage of this is module system enables reusability and separation separation of components. So module system enables reusability and separation of components. Clean separation of components. You can reuse the components, contracts, library, everything you can reuse. That is what actually we need. Now, how to create modules, how do we use them in a project, we will see. Let's see one hierarchy, how to handle that. Actually, every TypeScript file, every TypeScript file is considered as a module. Every TypeScript file, JavaScript files are considered as module. Every TS file is a module. So every TypeScript file is a module. So create a demo.ts and this is a module. This is a module actually. And what is the module? Module name is. In this module, what you can keep in this module? You can have variables. So we can have variables. We can have functions. We can have functions. We can have contracts. You can have contracts. You can have enums. You can have classes. You can have all these in a module. We can have all these in a module system. So this demo is a module now. In the demo module, you have all these members. So any JavaScript file, any TypeScript file is individually considered as a module. It is considered as a module. Now, whatever you define in module, that means every member configured in module is accessible only within the module scope. Is accessible only within the module scope. Every member configured in module is accessible within the module scope, right? So if you want any member accessible outside module scope, then mark it as that export. We were doing this every day for functions in JavaScript files. We were doing this every day for classes in JavaScript files. That is a common thing in general module system. That means you define anything in a module. So that means you have to set function 1. We have to write like export interface and interface name. We have to write like export class and class name. You cannot export a variable, right? Variables are intended because variables were LET const keywords. They are accessible within the scope of module only, not outside, right? That is important. And one more point, we learned already these basic things I explained, but now you may be learning detailedly. Actually, JavaScript also same concept will be there, and already we discussed that every module can have one default member. Am I right? Already we discussed that every module can have one default member. That means export default function F1 define. There cannot be multiple default members, only one default. What is the purpose of default? It loads into the memory by default whenever the module is configured in any file. Whenever you import module, automatically this default member is ready in the memory. So based on whether it is default or not, you can import. Am I right? You can import module members using import statement. You have to do that by using import. So that means how do we define import? And it is non-default, right? You have to use non-default. You have to use non-default member from the module name. You have to define the module name. You know this. And if it is a default member, what we have to do? Default from module name. You cannot use that curly brace. And if you want to import both default and non-default, then you have to use import default, comma, and non-default members from the module name. That's how we need to do. These are all the methods. If there are multiple non-default members, you have to use a comma. You can add multiple, but there can be only one default. This is actually default member, better. Huh? So don't think that it is default keyword member, that is. This is technically how you configure the library and use it. Let's see a simple implementation. How really is built in a project, right? Let's see. Means how the libraries are built in the background, how they are provided to you. Actually, for that, you see here, we are using in this, let's go. And here we will build one. I will create a folder here. Just roughly, I'm creating a folder by name library. I am creating a folder by name library. In that library folder, I will add subfolders, contracts. All our contracts we will keep in that location. Another folder, templates. All our templates we will keep there. Another folder, components. All our components we will keep in this folder. That means we will cleanly separate everything now. So contracts, components, everything. Now here, so we will go to contracts and add a new file, product contract.ts. Now here we will design a product contract. You can have multiple. That means I have interface and what is the name? Product contract. And this contains name, string, price, number, quantity, that is number, total is a method, so which is a number, print is a method which is an void. Now I want to make it accessible outside. We need to access outside. Then how to access outside? We have to just use here as export. We need to mark that as export. In this you can maintain multiple, but means you can create another interface also. Export interface, this is category contract, like this. And in that we have category name, so which is string type. You can maintain this in a separate file, or you can keep it in the same. Now suppose this product contract is default. We can mark it as default. You cannot have this also. There can be only one default member. Okay. Contract is ready. We will keep all contracts in contracts location. In the contracts folder, we will keep that. Okay, let's go. The next step, templates. Build a template, product template, .ts. Now here we are creating, so export template, export apps class and the class name. You know, template means abstract. And here I will say product template. This product template have to implement the contracts, but they are present in a separate file. Then what we have to do here? Import. We have to import, and we have to import. One is product contract. We have to import product contract from contracts contract file. It is already imported. And suppose, because it is a default member, I put in a curly brace, that is not valid because it is marked as default. Default members must be defined directly. Okay. And comma, non-default members must be defined in the base. Here we have category contract. That means the two contracts are ready, right? Okay. Now I want this template to implement those contracts. That means it implements two of them. What is it? Product contract, another one category contract. Now we have to design accordingly. So that means we will define public. So we have name, what type, string type, we will put some num. So we have public, some is a number type, and it is, we have quantity, that is also number type, some initialized with number. And we have public abstract. So total is a number type method. We are not implementing it. That's why we marked as abstract. Then public abstract. So print also a method, void type. We are not implementing. And we need to define public category name, which is a string type. It is empty. All are defined. But your template is having some members which need to be implemented. Now, where to implement this template? So we have to implement the template in a component. Let's go to the component, and we are adding a new file. What is it? Product component. Yes. Now, in this product component, we have to import. What is it? Product template from templates. From templates, we have to import this product template. And now we need to design export class product component. This component is going to extend this template. You know that we have to use extends what? Product template. And in the extension, we are defining name. Name is string type. We need to put some value into it. So name is equal to some value. Suppose some name. Okay. And we have price, and we need to put some number into this. We have quantity, and we have to put some quantity. And category name, and we have to put some category name, electronics. To implement the total method, this method should return this dot quantity into this dot price. We need a print method, which is an void type, which should print all details. Console.log, it have to print the name, this dot name, and it should print the price, and that is this dot price, and the quantity, this dot quantity, and the total is equal to this dot total, and the category is equal to this dot category name. These things we need to implement. That's done. Now your library is ready. Now you need to use this library in your application. Now you built a library with all of you have ready-made components. Now you can just use them in your project. So what we are doing here is we are adding a new folder, and the folder I am giving app. In this app folder, I am adding a new file that is index.ts. Every app starts with an index, right? Now in this index, we have to just import. What to import? We have to import just component. That's what we were doing in our React. Our React app index page is using directly the components. But actually component is built from templates. Templates are built from, templates are designed from contracts. That is the hierarchy of actually. Now here we created the component. Just what we have to do, let tv is equal to new product component. That's it. And through the tv we can access print method, which will print all the details. This makes your application simple. But behind this, lot of library is designed, right? Like this, generally developers, that means you are learning some technologies, Java, .NET, Python, PHP. There you are using some ready-made classes. Those classes are built by some developers and they are provided to you. You are learning how to use those and build an application. So every time you will not get a chance to build the library. Many times you have to just use the library built by somebody. Usually our architect team will be there, which will be designing the library for app. This architect team builds the library and provides to developer team. Developer team just uses that library and builds the application. Challenging one is architect's job. Why? Because they need to design a class in such a way that it should serve for that particular purpose. Now what you are doing, you are just using the class and building the application, right? Your work is simple, but the design behind it is complex. So see now, if I want to know from where this came, how it is designed, so right click and go to definition. Right click on that class name, select go to definition. It will take to you the component. That means it is designed by using this component, and it is using which template? Product template. You want to click and go to definition. It will take you to the template from where it is coming. You want to know what rules it is following. You have implementing template, contract, right click and go to definition. It will take you to that location. This is a lengthy hierarchy of application. Now what you have to do, just run this index page. That means let's run this index. We need to just start that index. I'm just using tse index.ts. We are compiling that index in the app and we are just using node index.js and it is executing everything. That is how we build the library and we manage the library and use the library for our projects, right? This is technically one thing you need to understand how the libraries are built. This is module system, right? How we use the modules. Now I will upload those all files. Example, you can try them, right? All those files I will upload, you can try. Now this is enough. Actually, this is enough to understand how TypeScript works. TypeScript is used. But in rare cases, sometimes when you are working with these libraries, you will come across with another concept called namespace. Namespace. In TypeScript based technologies, it is technically this namespace is one more concept you will hear, but you will not directly use it regularly. And the namespace is very common for the people who are coming from Microsoft technologies. They have these namespace based libraries regularly. Now, we don't need that. We will not directly use. For us, Angular, React, and all these people, modules are enough. Module system is enough. Namespace is larger than that. Namespace is larger than that. It is little bit good for handling different types of libraries at higher level, but it is not required everywhere. Actually, namespace is nothing but every namespace is a collection of subnamespace and members like contracts, so like templates, like functions, like components, like variables, all these, etc. Now it is same like module only, but is at a bigger level to design good architectural interface. I am not showing how to run them here because we have to separately configure and install that. I'm just giving you the outline introduction only for this. It's a very big concept and it is not necessary for you. These are for the people who work on Microsoft based technologies. They learn in those technologies in future if they are dealing with. But what's here, we have to use this. Actually, namespace is nothing but, suppose at higher level in projects, we will come across with some issue like, suppose we have project A. This project A, in this project A, so two teams are working. Two teams are designing. So we have team A and we have team B. Two teams are working and they are building library for this project. And this team built a class, that means this team built a class called class 1. And this team also builds a class, so it builds a class 1. Both teams have different library built, but they are having same names of classes. This leads to a lot of ambiguous issues will come. So this is very common actually. That means generally doing the same type of functionality, sometimes different approaches are present. And developer will choose which is best suitable for his situation. That means the same work can be done in several ways. For example, you have to access an element and use it in JavaScript. You can access by get element by ID. You can access by query selector. You can access by name. You can access by tag names, class names. Now the question is why you have so many things for the same thing. That tells the situation, right? That means in a situation where I cannot any IDs, then I have to access by using tag names. And in a situation why you cannot give ID, because already ID is used by some CSS or some. That means many times we need to build such libraries in a project environment that same names but different situations. Now, how to use them? For example, I want to use the classes designed by these two people. That means I want to use the class 1. That means class 1 is having function 1. And this class 1 is also having some function 1. Now what happens is, how do you handle this? How do you import? That means, so you are importing so class 1, you are importing class 1 from suppose like team A, right? Now you are importing class 1. This is also different from where? This is from team b. But what is the problem? You are using a function now belong, this function belongs to class 1 of team B or belongs to class 1 of team A. Issues will come. You imported separately, that's okay, fine, up to that it is fine. But what about how to access the members in that? To handle these kind of issues at higher level, we can build so good library by using namespace. Now you can do, you can use the team A. We can configure that one belongs to some team A. So this team, you can import function here. And when you are importing, suppose you are importing a class only here. When you are using the function, you can use reference of team A, class 1 in that function 1. You can use like this. It's very good. It's very easy. Now, this is called fully qualified names. We have fully qualified names. We have aliasing also. Aliasing means we can give a shortcut for it. So we can use fully qualified. That will reduce the problem. That means function 1 is working. Team B, class 1, function separate now. There is no issue. This kind of difficult in a module system. This is possible in namespace system. Namespace system. That means generally what we do now here, we will create similar type of library. So let's close this and see what I am doing here. I will create another folder. So namespaces, right? Namespaces. I create a folder called namespaces, separate like a folder called namespaces. In this again, we have subfolders, contracts, and another subfolder. So what we have? Yeah, another subfolder we have templates, and another folder we have components. Same like this we design. Now we go to contracts and add a new file. What is it? Product contact.ts. But this time, while designing the library, we use namespace. Name. Namespace is project A. That is the namespace. In that namespace, we can have subnamespace. We have a namespace. This is team A. That means in project A, team A and team A related classes are present here. It is a contract. Contract means we will use interface. Interface, suppose product contract developed by team A. Or simply here I am giving as separate as contracts. Understood? And this I just give as project. In project, we have contracts. In contract. Now everything need to be exported. You have to export this namespace. We have to export this contract. We have to export the main namespace. Understood? All need to be exported. Like this, you can go any level of hierarchy. Now, how to access this with reference of contracts? In contracts, what? Project. Now, in this, we are defining name is a string type. Price is a number type. Same quantity is a number type. And we have a total. So it is a method of number type. And we have a print, a method of void type. All these are defined. All we are configuring and we are defining it. That means it is using all this and specifying. Right? Now, important is in this approach, what we have to do is to use this inside some templates. Let's go to templates now and a new file. What is it? Product template.ts. Here what we have to define again, export namespace. Our main namespace is always what? Project. In this project namespace, we have another namespace now. What is the namespace? Templates. In this templates, we have to create export class. What is this? Abstract. Abstract class. What is it? It is a product template. Product template. We are using product template. But how to use those contracts in this file? This is not direct module system. Then how to import namespace? We have to use a / directive. We have to use a / directive. / we use here a reference keyword. Reference uses a path, and the path will define where is the file. Where is the file? /. It is present in contracts. In the contracts, we have which file? Product contract.ts that we have to import. This is how we import a library which have namespace. We can so this is at a higher level, very higher level than module systems. And at very large scale applications, you will see this kind of interface. Means these kind of libraries are built. Now, very important is how to use that contract. There are so many techniques. You can use fully qualified. That means this implements, okay, which contract, how to access the contract. You cannot directly access. We have to access with reference of project. Project is a namespace. In the project, we have contracts. Understood? In contracts, we have to access what is the contract? That is product contract. That's how we need to define. It is showing error because currently our project is not using namespace. We are using module system now, common JS module system. So for that, I told you who are implementing the namespace systems. So this is how they build. You can use aliasing names. Aliasing names means instead of doing this, what you can do is at the top here, we can use import. So we can use import, and here we can give import contract. Okay. And contract is actual contracts. And here we can get the namespace. What is it? Project is the namespace. In that contracts. That's how we define. This is called aliasing. Now what you can do, you can access with reference of contracts. With reference of contracts. That means here what you can do, implements what? Contracts dot. What is the contract name? That is product contract. That's how we do. And we have to write all the implementation part. This is building a library at higher level. Right? This is completely not required for you. So don't worry about this. But you should know that there is a concept called namespace. And this is for the people who are dealing with technologies like Microsoft base. There they will obviously learn namespace, like .NET people. Their daily life starts with namespace only, programming. Their library builds with namespaces only. The complete library is built with namespaces, and they know everything about this. But our React is not using this namespaces. We are working with only module system. So stick to it. You don't need to worry about the others. Just only the approach you have to understand how it is designed. So I just given an overview. We will not do anything here related to the namespace, right? Just I will give a simple syntax. How do you configure? We have export namespace, and this is some project. In that, what we do, we have export, we have namespace. This is like some contracts, and in this we will have a contract. That means here we define export. So interface and the interface name. What is it? Product contract. That's how we need to manage. And all the members you need to define here. How to import this? We need a / directive reference path is equal to, in contracts we have product contract dot ts. That is how we need to import. That's how we need to configure. And how to access? So we have to access by using project. In that project we have contracts. We have to just import that contracts and we can access and use. And any contract name directly, what is it? Product contract. That's how we need to do. These are basic things you need to understand, but no need to try these as of now. This is all basically you need to know about TypeScript and its infrastructure. Actually, this knowledge is enough. Even if you have to use TypeScript with Angular or Vue or some other technologies, this is enough. Whatever you learned here is enough. Now, how to use this in our React application and what the new things you will see in the React environment, let's see. Now we will see how we can create a React app TypeScript. Create a React app with TypeScript, and we will see the infrastructure. How actually is there any difference between the previous and now, right? And for that, what we have to do, we have to use npx. We have npx create React app command, create React app, and the app name, you have to give the app name, and in that you have to use a template. Which template? TypeScript. You have to write like this. If you don't use the template, by default it will take JavaScript. So template TypeScript allows you to create a React app with TypeScript as the language. Without the template TypeScript, it will automatically use JavaScript only. You have to create an app. Let's create an app. Already we know how to create. Let's check into D drive somewhere. Yeah, here we are creating npx create React app, and app name is React TS project. Something like this I am giving. React TS project. And what is it? Template. Template is what? TypeScript. So we are creating a React application, React TypeScript application, and React TS project, and it is installing all the library for TypeScript. So it is creating a React application with TypeScript as language. We will find out what is different from our previous project. What is changing here? Is there any drastic change in this, or no formal changes which are easier to understand, right? If you are already aware of JavaScript, actually nobody even need to teach you TypeScript React. Means TypeScript React apps. Nobody need to teach you how to build it. That just you need to know the commands and templates, and you can, by seeing it, you can understand what it is, and you can easily manage your options. Only the point you will have to handle differently is while consuming APIs, designing the forms, fetching the data, posting the data. This time everything is strongly typed. That means you need to declare variables with strongly typed. That means string type, null type, string type, number type, null or undefined type. You learned all the data types, you have to follow that. Right? And when you are dealing with APIs, fetching the data from APIs, you can use now generics contract yesterday, how generics can make your contracts, make your APIs data coming and strongly typed working for specific data type. Yep, it is successfully created. Everything is configured. Some more dependencies are there. Yeah, it is done. So, and you can see there is a TypeScript creating that a TS config is created for you. And you know the purpose of the TS config, na? You know the purpose of TS config. So why a TS config is created for me, we know that, right? That these are all ready. Now your project is ready. And let's see what is different now. Means there is nothing different in your compiling and executing. Huh? So what you have to do, just open the project folder. So that is in D drive. We have React TypeScript app. Yeah, TS project. And React TS project, this is the application. And you can see at high level, any change occurred in the folder structure. Only one change you will find, that is TS.js. Rest of things we know already, right? What they are. And in public, no change. Everything is same in public. In SRC, some change. And what is the change? The change is instead of index.js, you will find TSX. TSX is actually TypeScript extension, same like JSX. It's not mandatory. You can use direct TS. So TSX is just a syntax extension to tell that you are using JSX type syntax, right? So it is ordinary TS file is also okay. There is no problem in that. Right now you see, let's see the text file. You see that here there is no namespace related any tracks here. All are module systems only, right? That's the reason we don't worry about that. And see now everything is fine. So, and it is using all same things. Nothing changed here. And you go to your app component, app.tsx. Here also, any change you will find, no change. There is no change. There is no change in this. That means everything same. Only the point is now when you are, because functions not change in a TypeScript functions are same. Only when you are passing parameters, declaring variables, values, functions, then you have an issue. Then you have an issue. That means, let's see. Now we will run this project. Running the project, everything similar. What is it? NPM start So here we will add one component manually. And in adding the component, only the point now is you add a TSX file or you add a ordinary TS file also enough, right? Doesn't matter. Now here, so this is the index with app component working fine. Right now, let's go. I want to add a simple. So let's go to the SRC new folder. What is it? Components. In the components, I have to add a new file. This time login.ts. Login component or anything you want, right? Login.ts. So login component, login.component.ts. I can give any name, right? Traditionally, you can give TS or TSX. I will just give TS. So this is login component. Then how do we use this? So I will just use traditionally what we followed earlier. So login component dot ts. Okay. Now here we have to create a simple function here. So what we have to do, we need to create a function, and this function export, and we have the function name as login component. That is the function. In this, it is returning what to return, everything same. There is no change in this. So what we are configuring div, that is the container. What is it? Right. Where is that written? What is says? Why it is saying type? Acha. Type is not required. Let's check this. The type is not required at all. Let's name this as it's fine, right? So here TS file, so TypeScript file is only meant for building a library, not for interface, right? You build a library, use the interface in your TSX, right? Let's do that. That means actually what we have to do. So let me give a simple note here. One point is in this one simple note I will give here. So .ts file is to configure your contracts, your components. So, or you can say templates. You can configure your templates and the general library, templates and library. And if you want to use the TSX, this is TSX file. TSX is to configure. It is used to configure your functions, your components. You can say React components with markup. These two things we have to follow. That means you create your contracts, templates, and library in TS file, and in the TSX file, you have to use the TypeScript with markup. These are the two things. So if I want to use some library here, that means what we do, I will go here. I will just write here. This is suppose reasonably I will name it as, just for understanding sake, I will say product component. Okay. Product component.tsx. Product component.tsx, and I will add one file here. What is that file? I will add a separate folder. SRC have a folder. What is it? Contracts. In this contracts folder, we will add a TS file. What is it? Product contract.ts. In this, we will create an export interface. What is the interface name? Product contract, and it is having so name, string type, and number type, and stock some boolean type. Okay, now I want to use this in this component. We have to import. What to import? We have to import product contract from contracts. And here we are configuring a simple data. What is the data? Suppose I am declaring a variable. This variable is product. What type? It is of type product contract. It is of type product contract. It is of type product contract. In that case, it have to satisfy those rules. And what are the rules? It must have a name. Name is what type? String type. It must have a price. Price is number type. And it must have a stock. And stock is what type? Boolean. Now we can use this and present here, right? So that means here we will put a data list, a data term. So here we have name and data definition. And here we have to access, what is it? Product dot name. That is the approach we need to follow. This time, whatever you configure inside the component, it is strongly typed now. It is strongly typed, right? Earlier, we don't have strongly typed. So we can make it as any, by default, it is treated as any type. Here it is strongly typed. That means it strictly works for this. What is it? Another one, price and data definition. Here we have to define product dot what? Price. Another data term. This is stock. And here we have data definition. This is product dot stock. And we will keep this in index.ts file. Here we have to import, right? Import and use which component? The product component. So it imports the product component. And we are using the product component in the startup, which gets the details and display. Everything is similar. Everything is similar. Only the way of configuring your components will be important. They need to be strongly typed. Now let's hooks your change variable. I need to configure state, right? How do we configure the state? We define a constant, and constant what it is? Product, and what it is? Set product, and it refers to what is it? Use state. We have to import that use state and define. We have to configure the use state and define. And here, when you are defining the use state, you see it is an object type. It is an object type. That means it is initializing. But interestingly, observe here, currently I am not giving these details. Observe the definition of use state. So library is same, no change in that library. Everything is similar. Now you see this use state. You see it is anything new you observed here. Go to definition. It is a generic type. Use state. So you can see use state is a generic type. Now what you understood by this point here, it is a generic type. That is only the difference you will find here. That means if it is a generic type, so I am configuring like this. What is the type, right? I'm configuring the type. What is the type? So the type is what, suppose I passed here. So product contract type. Product contract type. In that case, what is the data to be stored inside this? It should be of product contract type only. That means you cannot store any object. That means it is not initialized. Let's try to access this product. It is currently not defined. It is not having any value inside it. Am I right? It is not you initialized inside it. Now I am accessing here. What is it? Product. And see, only these details are there in it. Earlier we can keep anything. Earlier we can store anything inside it, but now the state is strongly typed. That means you have to pass only these things into it. Nothing else. This is only the difference you will find while working with your data. That means now how your options are configured. Suppose I am using here. So use effect. Use effect is a function. And what this use effect hook is doing. So what that use effect hook is doing, it is using set product, right? And into that you can see, you can put only product type data into it. You can put only product type data into it. So that means it can have only that what name. And very important is name. So I defined some TV. Still it have a problem because as per the contract, so name is defined and any others are missing. What are missing? Price and stock. Because it is a contract following. That means we have to use an price is a number. Still we have a problem. So the problem is a stock, that is a boolean, true or false. It will not allow any kind of data now. That if I want string, use state, you can pass built-in types. Remember, if anybody asks how to your own types, means you learn TypeScript, have you learned custom types? You know, everywhere we learn custom type. So a class can be used as a type. A contract can be used as a type. Here we are using contract as a type. All custom types only. That means now you configured this and you can access. And now very important is, suppose anything additionally we are adding here. Suppose quantity is equal to 2. It's not allowed. We know the rules of contract. And anything is not mentioned. Anything it is not mentioned, it shows an error. And you know that in a contract, it can be kept as optional. When I keep as optional, then all these rules are now followed here. All these rules are followed here. You can define true or false. That is the basic thing you need to understand. And how we can present these details here. That means how we have product dot name. So and here we have the product dot price. The product dot price. So, and here I am not using this. And see now it is showing some error. And it says that, so it is a constant product undefined. Object is possibly undefined. Object is possibly undefined. Undefined means compile time, the value is not supplied. Already we done that. We are not initializing now. When we are setting the value into it, when you are setting the value into it at the time of loading the component, that means dynamically. That means why it is showing the product as a question mark. Why it is saying that? That means it is by default undefined. That means there is no value into it. At compile time, no value. It will here using this question, you can see those details same. Why it is referring to that? Why? Because it is initially not expecting a value. For example, suppose I will give here use state is a generic type, or I give as undefined like this. it is not possible. Already we learned, na? So union of type, because dynamically value coming means it is not undefined. It is treated as null. I told you that null and string or null and any another type. Usually this is a simple approach of configuring and defining your TypeScript content. So we have to configure this with a stock. Stock is an optional. Now, why this is configured as that? Because it is an undefined type, product, contract, or undefined type. So this is one simple point to understand. That means here it is using, actually it is a boolean. Boolean means you have to put some value. That means it will not return true or false. We have to just put the condition. If it is true, what should it false, what should happen? We have to keep here available. Otherwise, what should be out of stock? Like this, we need to configure. So with that, this is only the change you will come across here. That means strongly typed, and your use state is generic type. Generic type. Now, if I don't pass it as generic type, is it mandatory to pass? No. If I don't pass as generic type, for example, you see constant. So constant, say category, set category, and is equal to use state. I'm just defining use state, and it is by default treated as any type. You can see it is not undefined. Actually, it is ready to accept any type. That means here the values can be an object or array. Understood? You can keep a string, anything you can define inside it. That means any type will be applied to it at the time of running the component. At the time of compilation, if a value is not defined, then it is configured as what? Undefined. We don't need to worry about that. If you want to make it strongly typed, that means you see, you can keep it as string type. That means it should be, category must be a string or undefined. This is only the change you will find in configuring the data. All your hooks are same, all your functionalities are same, right? Only the point is the data type for the data you are dealing with is strongly typed. That's only the point you need to understand here. That is just what example, just I will copy this. So this is one example here. So example, this is product. So we have product contract.ts. In the product contract, we added this one. Right? That is one. Another one, product component.tsx. In this is the logic we have added. I will copy that and I will keep it here. So we will put it here. This is fine. Yeah. Copy. Yeah. And we are adding that here. This is a simple approach of how do we work with the TypeScript. Now we will see one simple example, how we can use Redux states, some external states, and design a small example. You can replicate all your examples here now. Whatever you've done with your previous JavaScript, everything, and you can create your own contracts according to the data coming in, and you can make it as any type, or you can fetch the data coming from API. According to API data, you have to create the contracts. Suppose we are fetching data from user's data table. We have to create a contract for the table, and we have to make the state of that particular user type. Then only user details are accepted. You can design that. Now you can try replacing your JavaScript with TS. Try that. One more option, how we can use some external states here. Is there any change? There is no change. Just I will show you how to use Redux-like states with React in TypeScript. The same you can try in JavaScript also, right? So how to use that? That we'll see in next session. Tomorrow we'll do that. Okay. Then we can see testing, deployment of applications, React applications, how to deploy into cloud servers. How do we set up all these things? We will see. Tomorrow I'll continue. Huh?